Thanks, Tracy, and hello. I'm Rose Waterhouse, the lead biologist here at Moral Compass. I've studied antibiotic resistance for the last 15 years, and its expeditious rise in prevalence is pretty much unprecedented. Many community and hospital-acquired infections are caused by antibiotic-resistant pathogens. Specifically, I'm referring to methicillin-resistant Staphylococcus aureus, or MRSA as it's commonly known. Given this context, and in conjunction with my colleagues, we've developed what we believe to be a critical and complete solution to both methicillin and penicillin-resistant and mutated bacterial cells. We've called it erythromycin. We've designed a gene network which was a closed loop. This means that we were able to effectively program the attack cells to both detect and eliminate the bacterial infections. This happens automatically when with accumulated use of erythromycin. This closed loop also has receptors acting like sensors, combined with a manufactured promotion element. This promotion element is scalable and actively seeks out lysostaphin. Now, lysostaphin is an enzyme which destroys Staphylococcus aureus cells. What erythromycin does is effectively program the immunomimetic cells to look for lysostaphin. Once the fighter cells have located the lysostaphin, they combine with each other. This chemical reaction allows the active and relentless pursuit of the Staphylococcus aureus cells, and only these cells. That's the key. Lysostaphin and erythromycin together is lethal to the Staphylococcus aureus cells. The image you're looking at here shows how biofilms promote the ongoing survival of bacterial pathogens. The biofilm, which is the yellow membrane in this picture, is a polymer matrix made from exopolysaccharides, proteins and nucleic acid. The biofilm, or the membrane, effectively protects the bacteria from any response by the immune cells, meaning the bacteria ultimately is untouched. That gives it the cause to both regenerate, mutate, and cause that resistance. As well as seeking out and destroying the staph cells, what erythromycin does is also breaks down or prevents this biofilm from ever forming. What it does, it combines with the protein, and it makes the formation of the outer layer of that membrane impossible. This exposes the bacteria and allows for the lysostaphin and the erythromycin together to destroy the harmful cells. In fact, in our studies to date, we're yet to observe the formation of biofilm at all. Erythromycin was developed specifically to treat, cure, and prevent staph infections caused by the Staphylococcus aureus bacteria. Staph infections, as they're commonly known, can range from minor skin problems right up to endocarditis, which is a life-threatening infection of the heart. Other symptoms of staph infections can include boils, cellulitis, staphylococcal scalded skin syndrome. Other more serious conditions include blood poisoning, toxic shock syndrome, septic arthritis, and the fatal endocarditis. I'll now hand over to Moral Compass's very own pharmacologist, Mr. Lewis Cruz-Smith. Thanks, Lewis.